Morning students. So myself Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So in my previous lecture videos, we are the discussion the subject called kinematics and dynamics of machinery. And in the last previous video, we have completed the part 1 of friction topic. The various introduction part I gave, how friction is happening, what are the laws of friction. Based on that, some problem we have solved in the screw threads also, friction in screw threads. Today we are going to see the continuation of that one. Again today the important topic, the mechanical drives, that is clutch, also we will complete in this session, as well as various few parts also we will discuss the frictional concept. So this slide already we have discussed in the previous video lecture, the syllabus of the unit 3. So these slides give a glimpse about friction of pivot and collar bearing. What does that means? Rotating shafts are frequently subjected to axial thrust. The bearing surfaces such as pivot and collar bearings are used to take this axial thrust of the rotating shaft. So the collar bearing, what it is taking means it will take the axial thrust of the rotating shaft. Propeller shaft of the ships and the shaft of the steam engine and vertical machine shaft are the example of the shaft which carries an axial thrust. Bearing surfaces placed at the end of the shaft to take the axial thrust are known as pivots. The pivot may have a flat surface or conical surface. When the cone is truncated, it is known as truncated or trapezoidal pivot, as shown in the figure below. Collar may have flat bearing surface or conical bearing surface, but the flat surface is mostly commonly used. There may be a single collar. These are the few sketch which I highlighted here. So problem under the conical pivot. Conical pivot supports a load of 20 kN, a cone angle 120 degree. The intensity of normal pressure is not to exceed 0.3 Newton per mm square. External diameter is twice the internal diameter. Find the outer and inner radii of the bearing surface. The shaft rotates at 200 rpm and the coefficient of friction is 0.1. Find the power absorbed in friction. Assume uniform pressure. These are the data. So you will have W equal to 20 kilonewton. That is 2 alpha is equal to 120 degree. Therefore, we will get alpha equal to 60 degree. So pressure, that is you have to take 0.3 Newton per mm square. Speed is given as 200 rpm. W equal to omega equal to 2 pi 200 by 60. That is 20.95 radian per second. Mu equal to 0.1. So in terms of this one, intensity of normal pressure Pn will be calculated with the formula, that is Pn equal to W by pi R1 square minus R2 square. Upon calculating, we will have a relationship. You will get the value R2 equal to 84 mm. Already we know that R1 equal to 2 into R2. Multiplying with 84 with 2, we will be getting 168 mm. Power absorbed in friction. This is the formula. These are the formulas you have to study. So T equal to 2 by 3 mu W cosecant alpha R1 cube minus R2 cube divided by R1 square minus R2 square. So already all the values we got. Just substitute in this formula and you will get the value of 301.76 Newton meter. Power observed in the friction is, power is nothing but torque into angular velocity, that is T omega. Upon multiplying, we will get 6322 watts convert into kilowatts, that is 6.322 kilowatts. Then friction clutches. So in mechanical component, wear will be more important to be get studied in the clutch. So friction clutch has its principal application, the transmission of power shaft and machine, which must be started and stopped frequently. This application is also found in cases in which power is to be delivered to machine partially or fully loaded. Force of friction is used to start the driven shaft from rest and gradually brings up to the proper speed without excessive slipping of the friction surfaces. So based on that friction, we will be calculating a single disc, that is plate clutch. This is the schematic diagram, it is highlighted here. So we have the clutch pedal. Whenever we are pressing, what will happen means there will be some disengage that will be happen. That is important. There will not be any contact between the engine and the power transmission. There will not be any power transmission. Whenever we release whatever, it will automatically engage. So it is mounted on the hum, which is free to move axially along the splines of the driven shaft. Then splines will be placed so that it will be completely, the pressure plate will be moved backward and in front direction. So basic formulas we have to go through in these clutches. Considering uniform pressure, that is important. When the pressure is uniformly distributed, we have to use this formula: P equal to W by pi into R1 square minus R2 square. W is the axial stress. Frictional torque on the elementary ring of the radius R and the thickness dr is Tr equal to 2 pi mu P R square dr. This is the formula. We are utilizing this formula. And total frictional torque acting on the frictional surface or on the clutch is given by 2 pi mu P R1 cube minus R2 cube divided by 3. Upon substituting these values, so upon a simplification, this relationship is also equal to mu W R. R is the mean radius of the friction surface. So this is the important term we are using only considering the uniform pressure. So two conditions are there. One is considering uniform pressure, another one is uniform wear. Wear means you have to use R equal to 2 by 3 R1 cube minus R2 cube divided by R1 square minus R2 square. So for uniform pressure already we discussed. Uniform wear means R1 plus R2 divided by 2. That is the capital R. Again substitute this value. We have the relationship. We are deriving the value. We are deriving the expression, and you will get half mu W R1 plus R2 equal to mu W R. Mean radius of the friction surface is equal to R1 plus R2 divided by 2. T equal to N mu W R. This is the formula, standard formula we are using to finding the torque. So one important thing we have to consider uniform pressure, uniform wear. These two conditions will come. So multiple disc clutch, already we discussed in the single plate clutch, the same option will be, same formulas will be used here also. Only the thing N will come, the number of plate, how much plate we are using in that. Only that case, again the same thing, uniform pressure, uniform wear to be taken into account. Again, based on the based on the problems, based on the formulas as we discussed earlier, we are going to solve one problem. Determine what is that means. Determine the maximum and minimum average pressure in the plate clutch when the axial force is 4 kN. The inside radius of the contact surface is 50 mm and the outside radius is 100 mm. Assume uniform wear. W equal to 4 kN, that is 4 into 10 to the power 3 Newton. R2 equal to 50 mm, therefore R1 equal to 100 mm. P max is equal to maximum pressure, therefore P max into R2 equal to C. Again we are using the formulas. This is the condition. Uniform pressure is maximum, means we have to use this relationship. Then we have the formula W equal to 2 pi C R1 minus R2. Upon calculating, we will get P max is equal to 0.2546 Newton per mm square. Minimum pressure. Minimum pressure means again you have to use the R1. The radius should be taken interchangeably because P max you have to take as R2 only, because maximum pressure will be accommodated in R2. So here P minimum into R1 equal to constant C. So we will get a relationship 100 P minimum. Then you have to use the formula and substitute C in that formula. Then you will get P minimum equal to 0.1273 Newton per mm square. Then average pressure, already we have discussed the formulas. W by pi into R1 square minus R2 square. 0.17 Newton per mm square. So these are the references This one reference I took for preparing this content. I hope this video will be useful for you. Thank you all of you for your kind attention. So kindly go through the formulas in this session, because studying the formula only we can solve the problems. There is no logical thinking. Only we have to study the condition, and for what condition we have to apply the formula. That is important in this session. So we will meet in the next lecture video for the same topic called friction. Thank you, students.